Hello everyone, my name is Jose Aurelio Fiorio Weberhofer. I'm an independent researcher in finance and economics. This video is a continuation of my previous analysis on the Paraguayan exchange rate, where I focus on agricultural export prices and their relationship with movements in the US dollar to Paraguayan Guaraní exchange rate. In this video, I extend that analysis by focusing on a different but closely related channel, monetary policy, and more specifically, interest rate differentials between Paraguay and the United States. The objective of this video is to examine whether differences in policy interest rates between Paraguay and the United States help explain changes in the US dollar to Paraguayan Guaraní exchange rate. This question is particularly relevant for Paraguay as a small open economy that is exposed not only to commodity price cycles, but also to global financial conditions driven largely by US monetary policy. From a theoretical perspective, interest rate differentials influence international capital flows. When Paraguay's policy interest rate is higher than the US rate, Paraguayan assets become relatively more attractive, potentially leading to capital inflows and appreciation pressure on the Guarani. Excuse me. Conversely, a reduction in this differential may lead to weaker capital inflows or capital outflows, increasing depreciation pressure on the currency. Before discussing the empirical results, it is important to address a key practical consideration. Paraguay's monetary authorities often adjust policy rates in response to changes in US Federal Reserve policy. However, these adjustments are rarely instantaneous or identical in magnitude. As a result, interest rate differentials can and do fluctuate over time, reflecting differences in timing, intensity, and domestic economic conditions. The estimated relationship in this analysis should therefore be interpreted as capturing broader monetary and financial dynamics rather than a mechanical or one-to-one policy divergence between Paraguay and the United States. To test this relationship empirically, I use monthly data. The exchange rate is measured as the nominal US dollar to Paraguayan Guarani rate expressed in natural logarithms. Using logarithm allows the results to be interpreted in percentage terms and improves the statistical properties of the regression. Monetary policy in Paraguay is captured using the Tasa de Política Monetaria, or TPM, set by the Banco Central del Paraguay, while US monetary policy is represented by the effective federal funds rate. The key explanatory variable is the interest rate differential, defined as the Paraguayan policy rate minus the US policy rate. The relationship is estimated using the following regression equation. Let's insert here the equation. the logarithm of US dollar PYG at time t equals an alpha value, which is the y-intercept, which is a constant, plus a beta value, which represents the slope, times the rate differential at time t, plus an error term, or epsilon at time t. Okay, so let's make this equation a little bit bigger so it's more visible. Let's make it 16 and control both. So in simple terms, this equation states that movement in the dollar Guarani exchange rate can be partially explained by how much higher or lower Paraguay's interest rate is relative to that of the United States. Now, to evaluate how strong and how reliable this relationship is, I focus on two key statistics from the regression output, the R-square and the significance F from the overall F test. So let's insert our regression statistics data. Okay, here we are. First, the R-square measures the share of variation in the exchange rate that is explained by the model. For example, an R-square of 0.40 will mean that 40% of the movements in the log exchange rate are statistically associated with movements in the interest rate differential within this sample. In my results, the R-square is 0.813. This tells us the explanatory power of the model, while also reminding us that rates are influenced by many additional factors beyond interest rate. Second, the F test, which is this value here, evaluates whether the model taken as a whole is statistically meaningful. In a simple regression like this one, the F-test is closely related to the t-test and the slope coefficient. But it is still useful because it tests the null hypothesis that the explanatory variables jointly have no effect on the dependent variable. In the Excel output, this is shown as significant F, which is this one, which is the p-value of the overall F-test. When significance is F is extremely small, effectively close to zero, we can reject the null hypothesis. with very high confidence and conclude that the interest rate differential has statistically significant explanatory power for the exchange rate in this sample. In my regression output, the significance F is 1.79 times 10 to the minus 12 power. Because this value is far, far below conventional thresholds such as 0.05 or even 0.01, it supports the conclusion that the relationship I estimate is highly statistically significant and that it is very unlikely to be due to random chance. The regression results show a strong and statistically significant relationship between the interest rate differential and the exchange rate. The estimated coefficient on the interest rate differential is negative, which is consistent with standard economic theory. The magnitude of the estimated coefficient allows for a clear quantitative interpretation. The results indicate that a 1 percentage point increase in the interest rate differential between Paraguay and the United States is associated with an approximately 21% appreciation of the Paraguayan Guaraní against the US dollar. Let me rewrite now the equation now that we have the numbers. So this is the alpha value here. So Control, let me copy this. Control C. And that's our alpha. And our beta or slope is this value here. Negative 0.21. It is important to clarify that in practice, it is unlikely to observe an immediate 1 percentage point change in interest rate differentials. Central banks typically adjust policy rates in smaller steps, most commonly 0.25 or 0.50 percentage points. Using the estimated coefficient, a 0.25 percentage point increase in the interest rate differential will be associated with an appreciation of approximately 5.25% of the Guarani. A 0.5 percentage point increase will correspond to an appreciation of approximately 10.5% of the Guarani. To make this more clear, suppose that today the exchange rate is 6,500 guaraníes per US dollar. A 5.25% appreciation will imply a new exchange rate of approximately 6,160 guaraníes per dollar. A 10.5% appreciation will imply a new exchange rate of approximately 5,820 guaraníes per dollar.